Okay, this is my prototype microwave ray gun. Um, it's prototype because I haven't hooked it up yet, but in theory everything should work, and the circuits and everything are here. I just have to test it out. I haven't put it together and tested it out yet, but this is my microwave ray gun. It runs off of a 18-volt lithium-ion battery. Okay, that's an 18-volt lithium-ion battery. This one's actually been destroyed because I hooked it. I had it charging off of a high voltage system, which actually ruined some of the plates. So now this is a 12-volt lithium-ion battery. I haven't tested the amperes yet on it per hour, but this is now a 12-volt battery. And this is our inverter here. This is a fucking 140-watt inverter. It ramps the current from the 12 volts up to a 120. Now, the circuit here is actually completely inefficient because, well, okay, I'll explain that in a minute, but this is an inverter, ups it to 120 alternating. What this does is then it goes into here, which is our driver circuit for our flyback. This driver circuit is a CFL, 13-watt CFL driving circuit for a compact fluorescent bulb. That circuit is able to drive our transformer. Our transformer runs off of 13 watts from our CFL compact driver circuit. It gets bumped up by our flyback transformer to about 30,000 volts. I haven't been able to test the amps on that yet, so it's approximately 30,000 volts running at 15 watts. So it's not a very lot of current, but obviously you can do the math there. It's pretty small. So here's our homemade foil capacitors. We could substitute in one of these guys, boom, to do the job. But right now I'm going to try running it off of my foil capacitors. When I put the circuit together, I may put one of these in just for sturdiness and handiness and, easy operability. There's our magnetron. So basically our high voltage out comes off of here. The reason that this system will work is because this flyback transformer actually has a diode, a very high voltage diode built into it to allow the current coming off of here to be positive only. It has to be positive only because that's the way that the electron gun inside the cathode ray tube works. It needs a positive side and a negative side. Notice the cathode ray tube. It has to have an anode and a cathode. So this is a DC 30,000 volt DC power supply, which runs off of very minimal 13 watts at 120 volts and bumps it up to 30,000 volts of DC current, fills these capacitors. This is our negative lead, this is our positive lead. Then we will hook that up to our magnetron. This is our magnetron here. We have not tested this one yet, so I don't know if it works, but I have a bunch more of them, so the system will eventually work. And there you go. There you have it. That is as good of a schematic as I can get right now. I'm not going to draw it out, but that is the microwave ray gun schematic. Or not schematic, but prototype.